Hello friends, so welcome back to my channel. In this video, in this session, we are going to discuss about vector databases which are going to be used in the RAG pipeline and the internal details, and we are also going to see demo of two vector databases. So let's get started, and before I start, I just want to have a recap. So on my channel, if you open this playlist called as AI Generalist, where I've started all the videos about the RAG. So just to have a recap, so I started with the data collection step in the RAG, and then data reorganization into markdown file, and then data cleanup and cross-source deduplication, and other steps like chunking strategies, uh, couple of chunking strategies, chunking strategy, and the embedding step. So this video is going to be the next part of this, that is going to be vector database. And the source code which I'm going to discuss here is also available in this particular repo, and the link is there in the description, and all the details are there in this particular GitHub file, GitHub repository. So let's get started. Now, vector database. So it stores the embeddings and enables similarity search for fast information retrieval. We in the RAG pipeline we need databases, we need data which we can extract easily and seamlessly. That is where we use vector databases. Storage. So your documents are broken into chunks and turned into numerical lists called as embeddings. These numbers represent the meaning of the text. Okay. Right. Retrieval. When a user asks a question, that question is also turned into an embedding. The databases performs a similarity search, mathematical distances to find the document chunks that are most related to the query. These are important concept because when we see the actual practical, where we will also see the distance between the embedding of the query and the distance of the closest match retrieval from the database. Okay, context injection. So the database hands those relevant chunks to LLM. The LLM then uses that specific info to answer the prompt accurately, rather than just guessing the based or biased on its internal or on its original training. So this is just the definition part. We in the demo we are not going to touch any LLM, but we are going to talk about these two. So let's get started. Again, the vector databases, so it converts the text into numerical vectors that capture semantic meaning. So these are the purpose-built vector databases which are popular, widely used, and fit with multiple requirements. So Pinecone, best for managed zero ops production. Viviet, best for hybrid search and modularity. Milvus, best for massive enterprise scale. Quadrant, best performance to cost ratio. And ChromaDB, where it is best for prototyping and local development. So as the name says, for local developments, we are going to see a demo of ChromaDB and Quadrant on my local. Okay, so let's see one by one each vector database. Pinecore, as it's why it is popular, it is fully managed serverless cloud service. You don't have to manage any infrastructure, making it the go-to for teams that want to go to production quickly. So Pinecore is for that, and of course it is a paid one. Okay, best for production grade RAG, where ease of use and low latency are priority. Is a priority. Okay, Vivian best for hybrid and modularity. So it excels in hybrid search, combining keyword matching with vector similarity. Also has modules that can automatically handle your vectorization. Best for content heavy apps where exact keywords like product names are important has general meaning. Okay, so this is also paid one. Then we have Milvus. It is highly scalable and can handle billions of vectors. So performance is one parameter here. Open source, uh, best for large organizations where complex distributed data needs and the engineering resources are managed. Resources to manage it. Okay. Then comes the quadrant, which is the part of demo. So best performance to cost ratio, written in Rust programming language for speed and memory efficiency. It offers very fast filtering on metadata alongside vector search. Best for complex filtering requirements, searching only within the specific user categories or date ranges at a lower cost than Pinecone. Okay, so cost is one, performance to cost ratio. So that is a selling point here. Okay, then ChromaDB, so best for prototyping and local development. So yes, extremely simple Python first setup. You can start a local vector store within with just a few of lines of code. Yes, and small scale projects, educational tools, rapid prototyping before moving to the large databases. So that is the advantage here. Okay, so let's see a demo. And in the demo, by the way, this, as I said, the source code is available here. So we are going to see ChromaDB and the quadrant DB. So ChromaDB, right? So ChromaDB, we need to have this particular packages installed and all. So in ChromaDB, we need to have we need so initialize a persistent client. So I'm going to have a client called as my local DB, and you will see here once I run this, there will be one folder created, and that will be my local DB. In that, there will be one SQLite database and some additional metadata. Okay, so then I have to call certain functions. So by the way, this setup is for persistent client, and I can also have in-memory client also. It is the same, just that the RAM requirement is more and there is no storage. It's just on the fly. Okay, then we have to call the default embedding function, and then we have to have a collection where we can create a collection or get a collection with the default function, and then we will be adding some kind of a info or embeddings or documents, okay, in this collection. So there are certain items we have added. We can say it as a document, and there is a metadata for it. So it is a security category, API, DevOps, and development. So everything is having a category and the actual document content. Okay, and there is an ID associated with. So there are four entries everywhere. You see, there are four entries everywhere. Again, this is for the quick prototyping and for demo purpose. In real world, there will be a lot of things which can be dynamically added, as IDs or metadata and document, right? So then, what is the query? So how to log in? Okay, so uh, how to log in? So if you see, these are the source of information or vectors which are stored in database, and we are going to query this for the question what we have. It is also a text. So this will be also converted into embeddings, and this will be also converted into embeddings. And what will be done is, what is the closest match or these words or these converted embeddings from this, that will be given as a output. Okay, so here we search for how to log in. So if you see, even though that phrase is not in our documents, there's no login related thing, but something which is closest related is probably this one. We set password and those things which is related to login. Again, authorization we header also related to login, but authentic, token generation, this is not related to login. And this is again some build concept, okay, building a code or something. Okay, so now what we're going to do is we're going to raise a query. We can raise a query as a list. We can raise multiple queries. There can be multiple queries, and what we want is, we want the top first result or top two result or top n result. So for now we are going to check only one, okay, because it's just a demo. So these results will have, so we will have a query, we will have the results document, and we'll have a category. Okay, so let's run this and see. Okay, so how to log in is the query. So the retrieved context. Okay, so if you see, this is a retrieved context. This may not be the exact answer. Okay, may not be the the question and answer. It is a query and there is a response. So this, as I said earlier, this is the tentative relevant chunk or information retrieved from this particular data set or collection. Okay, and the category is security. Also, further we'll also see, in the subsequent example, we will see the result score, how closely it is matching the vector databases on. So we will see that also. Now this, what we have seen is a developer side or implementation perspective. Okay, now being from the automation or from the testing side, I want to validate this. Okay, so whether the database my local DB, yeah, you can see this is created and there is a SQLite file. So um, whether the the tokens which I have given and whether the query which I have given, based on this whatever response I am getting, okay, retrieved context, whether it is match, how much is the match percentage and all. So that is the QA part or the automation part, right? So let's see that QA1. So I'm using a different database, my local DB. So as of now there is no my local DB. So what I'm going to do here is I'm going to add two documents, okay, and I'm going to raise a query which is a one word only. So there are um, different logics. So this is called as keyword search, and one more what we have seen earlier is a semantic search. So keyword search is I will give one word query, and whichever is relevant to the most relevant chunk, most relevant embedding for this particular query, that all queries will be returned along with the ID and their score. Okay, so yeah, steps are similar. So I have to set up the Chrome DB, then client, and then collection, and then in the collection I need to add certain documents and IDs and metadata and many things. Then I'm going to do a query, text query. So collection.query, I want only one result or the top first result and the results. Okay, and so what are things I can verify is whether the result is found or not. So okay, so there is a relevant chunk present. Okay, then the chunk returned, that length of that particular chunk, is it greater than zero, otherwise error. Then this particular text, so London, query has queried as London, so whether that is present in the response chunk or not. And I know because it's a ID 002, okay, second one. So the returned ID will also be the same or not, that I'm going to verify, and ultimately it is passed. Okay, right. So I'm having the actual expected output and the actual output, and I'm going to compare that, right? So as I said, test is passed. Okay, it's very straightforward, not much complicated. Now let's take a different query, semantic query. uh, where is the office located? So this query, if you see, it expects some kind of a location or the name of the city or some kind of place. Now out of these two document or these two chunks, okay, this seems to be relevant, the among these two the most relevant chunk, which is matching the which might match the answer of, or which might try to have a response for the particular query. So that is why we will be getting same thing. Okay, so it is a second chunk. Okay, so it is passed. Okay, this chunk is returned. Now let's tweak a bit. So I'm going to have a new query. Okay, where is my toothbrush? So if you see this, this is basically not expecting a answer in a but in a city or a place. It is expecting something, okay, this toothpaste is on some table or in some rack or somewhere. But the what the rag I mean what the Chrome DB does when we do a query, okay, it finds the relevant chunk which is the most closest answer, and that is why it is also going to return this one. Okay, though it is not technically the correct answer, but whichever out of these two or out of all the available information, this seems to be the closest one, so that is what it is going to print. Okay, it is retrieved, right? The same thing is retrieved. Okay, now let's make it a bit more complex, right? So I have taken an e-commerce example. So there will be a DB called as e-commerce DB. So there is no e-commerce DB example here. Okay, so I'm going to take an e-commerce DB example. It is a persistent client. Okay, and I'm going to same thing. I'm going to call this default embedding function. Then have a collection, get or create a collection. I'm going to name it as tech docs, technical documents, and I'm going to add a couple of uh, documents category. So this is same we've seen in the earlier example, and we are going to ask question. Okay, how to log in? Okay, so how to log in this query is not exactly present, but what we are going to get is we are going to get the relevant um, chunk from the content what we have uh, relevant from the relevant documents what we have stored. Okay, so same thing here, except that we know what to expect here and what not to expect. Okay, yeah. So category security. Okay, so okay, we are going to see this e-commerce DB. Yeah, e-commerce DB. So I have taken an e-commerce example where I have some products and their features and their adjective. Okay, so I'm going to do. I'm going to add a 100 row document um, in the embedded in the vector database, and from there I'm going to query the required information. Okay, so this is something which will create a unique database based on these three lists. Okay, and I will go, I will have a persistent client and then create collection, and I'm going to insert the same product list. Okay, so I'm going to insert a product list of 100 rows, right? Okay, and after that, for I have a query which is comfortable seat for work. So I have this kind of products. So headphones, coffee maker, yoga, this official paper, official chair, paper bank, and something. So what we're expecting is something which is official office chair, or something which is relevant to the sitting, or a office chair or something. So obviously we don't want it as a microwave output or dishwasher or some other category. So this is something which is relevant to sitting or office chair or sofa, something like that. Okay, and the adjectives and the features. Okay, so let me just comment out the next part for now. Right, so this is going to be similar to what we have seen earlier. Okay, so the additional thing is in the result what we are going to have is we are going to have the id of the result. Okay, the content and the distance, or the percentage matching result. Okay, so let's run it first and then let's see. By the way, here I am going to expect three results. Okay, top three results. Okay, because there is a lot of combination, so there will be three results, right? So if you see result 1, 2, and 3. Now, comfortable seat for work. So professional keyboard design comfort. So this is keyboard related. This is not um, related to anything which is for seating. Portable office chair. Yes, this looks good, matching. And advanced speaker with ergonomics. This is not relevant. Okay, but if you see there is a distance. Okay, so professional keyboard designed for comfort, and if you see the word is comfortable, so comfort word is there. So that is why this is the closest match. Or if you see the distance, which is, let's say, zero point 0.9 distance, this is 1.01, this, and this is 1.21. So there can be other places where there is a distance of, let's say, which is less than 1. Okay, let's say zero point 0.3. So what we are going to consider is the one which is having least distance. Okay, okay. Now, as I said, technically this might not be correct. Okay, because so technically what the um, vector database does is it queries and it finds the relevant words and this relevant score, and of course the word to word, if it is matching, then that probably is the earliest or the nearest matching chunks. Okay, so yes, definitely there is a chance to improve on this. Okay, but we have seen one example. Okay, now let us see one more example. Instead of one query, I have other queries. Okay, so I have already added the rows. Okay, 100 rows in the DB, and I'm going to have 10 questions. So something to keep me awake during a long night shift. Okay, so these are the first five questions are like medium difficulty, and this again remaining five are harder difficulty. Okay, so waterproof outdoor gear with a rating of 4.5 or higher. So this is very difficult to find a match in the 100 entries what we are going to make. and that is where we are going to see the result. Okay, so again we will see the query id, document, and distance, and let's see. So here also I'm going to find the top three results. Okay, the top three results. Okay, so let's run it. Now, because 100 parameters are going to be added in the db, so it is taking them some time, and the retrieval is very easy. Okay, so there are 10 retrievals into top 3, so 30 retrievals are there. Okay, so let's take some random stuff. So okay, a premium wireless audio device under $150 that is currently in stock. Okay, so portable tablet noise cancellation. Okay, that is the first match with the distance is 1.13. Then professional headphone. Okay, this seems to be good match, uh, although the price thing is not mentioned. And wireless monitor with ultra quiet operation. So wireless monitor, not exactly something which is audio device. Okay, so the score is again it is not that good, so we will ignore this. The score which should be a typical score should be something which is within, let's say, zero point 0.8 or less. Okay, 0.5 or less. Okay, right. Let's take one more random. So we'll take this one, smart home lighting compatible with Alexa. Okay, so handcrafted desk lamp with Bluetooth connectivity. So yes, if you see this Alexa device, it is having Bluetooth connectivity. So probably that is the one which is matching. Then portable desk lamp, not matching. Then silent desk lamp with waterproofing. So desk lamp, desk lamp, desk lamp. Okay, so if you see this word lighting, compatible, smart home lighting compatible. Okay, so something which is related to lighting. Okay, so that is why this lamp, lamp, and lamp are coming into picture. So this seems to be a relatively a good match, and the score is still not in the range, like not less than, it is more than zero point 0.8 and above. So probably also not 100% match. So like this we can improve on, we can do a fine tuning, right? So let's see one more. So here also, okay, so there is some additional metadata which is in stock and rating. So four metadatas are there: price, in stock, category, rating, and I have again this all products. Okay, so and other features, other categories of information to be passed in the database. So let's see. So test case, this is a bit complex. So the stay awake night shift, cluttered desk wires, home cardio, again audio under high rated fitness. So little complexity is there. Okay, and if you see this additional less than, greater than, so these are additional uh, uh, keywords we can use for the embeddings or for the vector database to extract relevant info. Okay, right. So again I'm going to insert a few records. So if you see, I'm going to insert 100 records. The database name will be e-commerce rack test. So there is no e-commerce rack test. Okay, so these are the test cases, and then query, and then I'm going to have a result. Okay, let's just pass, fail, or whatever. So let's see. So I'm inserting 100 records first. Okay, and so if you see the query, this exists semantics and metadata, so there is kind of a tabular structure. If you see the earlier example, it's just the text match and the score. Here I have taken it as a tabular structure. Okay, so this way I can also find out, and also there is this semantic exact matching is not found. That is why we can see this question mark or exclamation mark logo icon, and like that. So from testing and automation we can do multiple things, right? Okay, so now let's proceed for the next demo, which is the next database, which is the quant db. Okay, quadrant db, right? So let's see from the development perspective what we need to do. So quadrant client, and I'm going to have a location which is eat memory, that is in the RAM. No physical, no folder creation, nothing like that. And I'm going to have an embedding model, which is, if you see, the model name is BGE small English V1.5. This model I'm going to use. I'm again going to have similar structure, like I'm going to insert some records. I'm going to create a client, the embedding model, and then create a collection where I'm going to insert this collection name, um, model, okay, this model, and yeah, this products. Okay, so I'm going to insert this products. So if you see, I have 20 products. Okay, okay, and I'm going to update or insert this. Okay, so there's a new word called as upsert, update and insert. Okay, this collection. Okay, right. After that, uh, my query is I want a thin laptop. Okay, out of this all uh, data or records, I want something which is a thin laptop. Um, and I'm going to query this, pass the collection, then the query vector, which is going to have this query text and the um, query vector and so on. Okay, and I want to have only two results for now, right? And then I'm going to print the description and the score, right? This there's a scope to have detailed info about this code, okay, but for the demo purpose, I'm just going to run this. Okay, so there are two matches. Yeah, what I wanted is thin laptop, right? Yeah, a thin laptop. So universal vertical laptop, okay, and water resistance laptop backpack, okay. So if you see, the score is zero point 0.7, zero point 0.7. So as I said earlier, something which is below zero point 0.8 is okay, within the range. This seems to be good match. Okay, now let me check something which doesn't exist. Okay, so simply I will say a portable winding machine, okay, or something, a fish icon. Okay, this is something which is probably not there in this product. Now let's see what we get. So icon, okay, so I have set it as icon. So that is not something which is matching. Okay, so we got something which is for frame and keyboard. So keyboard is not something related to icon, and the frame is related to some icon. Sunglasses, okay, so probably related to that. Okay, so yes, we can still do refinement, we can still do multiple iteration to query and so on. So there is a chance for improvement. Let's see the next one. Now this is the development perspective, right? So now from the automation perspective, from the testing perspective, what can we do? So again, the same data I have, okay, same code to insert something in the as a chunk or as embedding into a database, in memory database or physical database, and then I will have query, and I will there's a query, and I'm expecting some particular ID. Okay, so the ID is from this. Yeah, this is the ID. Okay, this is the ID I'm expecting. So this is something which I know by looking at the input, and I can have the expected output, and I'm going to evaluate, and I'm going to check the expected and actual output, and then I'm going to generate the result. Okay, right. So let's run this. Okay, now seems everything is passed. Okay, we found the required ID where we know that the answer is present, And also I have added two more lines where this particular item or query will not find any relevant result. Okay, so we'll get a no id or expected id is no match. So that also was successful, luckily. This particular thing is correctly ignored or not found. So even if the score is there, but it is not found. Okay, so yes, we can do manual testing as well as automation. Now, why automation matters? Because in real world, you know, in real world we cannot do everything manually, so we have to do automation. That is why this, not standard techniques, but one which can help us to automate day-to-day question, day-to-day developments, right? Okay, so that's about it. So if you like the content, please like, share and subscribe to my channel. Thank you.